Hello and welcome back. For this problem, we want to find the relative max and mins using the first derivative test for this product of two trig functions on this interval. And I need to change that interval very quickly because I actually wanted it to be from 0 to 2 pi, not 0 to pi. So let me change that to 0 to 2 pi instead to match what I planned. All right, so let's go through, and this always starts off with our derivative. So f prime of x is going to require us to use the product rule. Derivative of the first is the cosine of x times the second, which is just the cosine of x already, plus the first times the derivative of the second, which is going to be negative sine of x. Simplifying this down, we have the cosine squared of x minus the sine squared of x. And we now need to find our critical numbers. First of all, this derivative is never undefined because it's the difference of two squares of two very nice trig functions. So it's never undefined. However, it could be equal to 0. So we're going to set our derivative equal to 0 and solve for x. So it's going to give us the cosine squared of x minus the sine squared of x is equal to 0. There's many different ways to solve this trig equation. In my opinion, the easiest one is to go in and use a Pythagorean identity. And it doesn't matter which trig function we get rid of, so let's go ahead and replace the sine squared with our identity that it is equal to 1 minus cosine squared of x. So therefore our equation is going to be cosine squared of x minus 1 minus cosine squared of x equals 0. So that's cosine squared of x minus 1 plus cosine squared of x equals 0, or 2 cosine squared of x equals 1. So the cosine squared of x is 1/2, which means that the cosine of x is equal to plus or minus 1 over the square root of 2 by taking square roots of both sides. All right, so now this happens 4 times on the interval from 0 to 2 pi. It's basically your odd multiples of pi over 4. So we know that x is equal to a positive pi over 4, where we get our positive 1 over square root 2. We get x equals 3 pi over 4, x equals 5 pi over 4, and then finally x equals 7 pi over 4 on that interval. So now we're going to draw our number line, and remember we are actually starting at 0 and stopping at 2 pi. All right, next thing to do is plot those critical numbers, and so we're going to have pi over 4, 3 pi over 4, 5 pi over 4, and finally 7 pi over 4. And our derivative is equal to 0 at all of those locations. All right, next thing for us to do is now test out the sign of our derivative in between these endpoints of our interval. And remember, our derivative is equal to the cosine squared minus the sine squared. So first good number to pick would probably be the number pi over 2. If we evaluate this at pi over 2, you're going to see that we get a negative 1 for our derivative, because that's just the cosine squared minus the sine squared. So this is going to be negative on the interval from pi over 4 to 3 pi over 4. Something between 3 pi over 4 and 5 pi over 4 would be the number pi. Substituting that into our derivative, that would be the cosine of pi squared minus the sine of pi squared, and cosine of pi we know is negative 1, squaring that is a positive 1, and the sine of pi is 0. So that is a positive derivative at that location. And then we could look at negative 3 pi over 2, and in doing so, that's going to be 0 minus 1 squared, so that's negative. And then at 2 pi, we're going to be back with a positive derivative. And then back over here at 0, we also have a positive derivative because the cosine of 0 is positive 1, and sine, of course, is 0. So we have our sign figured out for our derivative, and this function's a bit of a roller coaster if you think about it. It is increasing, decreasing, increasing, decreasing, and increasing once again. But again, the goal of this problem was not to find the intervals of increasing and decreasing. Instead, it was to find our relative max and mins. So we can actually kind of answer this question with just two clauses, and we can say that since f prime of x changes from, we'll start with the left to right, from positive to negative at x equals pi over 4 and x equals 5 pi over 4. We know that f of pi over 4, if we go back to our function, that's going to be the product of the cosine and the sine of pi over 4. Each one of those is 1 over root 2, so multiplying them together gives us a 1/2. So that's a value of 1/2. And the same thing happens at 5 pi over 4, where they're both negative. We multiply the negative 1 over square root 2 times another. We're going to get positive 1/2 as well. So these are going to be relative maximums. And now we can do the same thing for the other two critical numbers. So since f prime of x changes from negative to positive at x equals 3 pi over 4, and again at x is equal to 7 pi over 4. We know that f of 3 pi over 4, which is negative 1/2, the signs are mixed there, and f of 7 pi over 4 is equal to negative 1/2, are relative minimums. So this function has two relative maxes and two relative mins on the interval from 0 to 2 pi. And again, you'll notice there's a bit of a symmetry here because we have a nice even function that we're taking a look at on our domain. Actually, it's even, isn't it? Yes, we go back.